So here we are in section 1.2, looking at segments and congruence. The learning target is clearly at the top of your notes, but just in case, just for kind of some reinforcement here, the learning target today is very simply to be able to successfully use segment postulates to identify congruent segments. Okay, so first of all, just some terms that you're going to hear throughout the chapter. In geometry, we use what are called postulates or axioms, and just understand that when you hear those terms, those are just rules, okay? Rules that are accepted without proof. You cannot prove them. We just agree on these ideas, okay? A theorem, on the other hand, is a rule that can be proven. All right, and we'll talk more about those differences as we progress through the chapter, but or through the semester, I should say. But just kind of a brief idea there. They're all rules. Okay, so the ruler postulate or the ruler rule is pretty simple. Okay, the points on a line can be matched 1-to-1 with real numbers. So if I put it on a number line, one point might be -6, the other point might be +3, whatever. Okay, and the real number that corresponds to the point is the coordinate of that point. All right, that's a pretty basic idea, nothing too crazy there. So here's how you find the distance between 2 points. You take the absolute value of their difference. Okay, you take the absolute value of their difference. Now, so notice here the distance between points A and B is written as AB with nothing over top of it. So if you just see two capital letters next to each other, that means distance. Okay, so it's the absolute value of the difference of the coordinates of A and B. AB is also called the length of AB, so when you hear the word length and distance, should be thinking really the same thing. And the other thing to note, remember absolute values, you should be familiar with these. Absolute values are always positive. All right, when you look back up here at the diagram, okay, just note it won't matter. You can do x2 minus x1 or you could do x1 minus x2. It's not going to matter because the absolute value is going to take care of that for you. All right, so it says measure the length to the nearest tenth of a centimeter. Again, you can pull out a ruler and do that if you want. We're not going to do much more beyond that. Okay, really what we're going to be more focused on is example 1, part B, where it says use a number line to find each length. So I want to find the length of DE. Okay, you could simply do this by just going from D to E. You go 1, 2 units. Okay. Or what you probably want to do is understand that the length of DE is actually the absolute value of 0 minus 2, or you could say the absolute value of 2 minus 0. Either way, you're going to end up with 2. Okay. If I look at BD, the length of BD, okay, well again, B is -6, D is 0, so it's the absolute value of -6 minus 0, which is the absolute value of -6, which we know is +6. The length of AE, okay, A is -9, E is 2, so I do the absolute value of -9 minus 2. -9 minus 2, that's the absolute value of -11, so the length is actually 11. Okay, the length is 11. And finally, the distance between A and C, or the length of AC, all means the same thing. A is -9, C is -4. -9 minus -4. Well, we know minus a negative really means plus plus. Okay, and so really what we're looking at is -9 plus 4. -9 plus 4 is -5, and the absolute value of -5 is just +5. Okay, so again, just finding lengths on the number line. Okay, 3 collinear points. When 3 points are collinear, you can say that one point is between the other 2 on the same line. Okay, this should make perfect sense. Okay, so I have 3 points here. I have point A, point B, and point C that all lie on the line. Well, clearly, if they're all on the same line, then one of them has to be in the middle. In this particular example, point B is between points A and C. Okay, remember again, collinear. We talked about it briefly. Collinear just means points that lie on the same line. All right. Okay, the segment addition postulate. Okay, a big idea. All right, it says if B is between A and C. So on this line here, let's go ahead and put here's A. We know that B is between A and C. Okay, so that's what we're looking at there. So okay, so if B is between A and C, then AB plus BC equals AC. In other words, what it's saying is that if you take this length from A to B, and you also take this length from B to C, and you add them together, you get the entire length of AC. Should make sense, okay? And we can go vice versa too. If AB plus BC equals AC, then that means that B is between A and C. That is the segment addition postulate. Okay, so example 2, find the length of RT. Pretty straightforward. Okay, so RT equals, I'm just going to go ahead and build right off that. So RT equals RS plus ST. We know the length of RS is 17. We know the length of ST is 8.5. And so we know the length of RT is just 25.5. We can say units, whatever. There are no units on it. So I'm not going to be as picky. If I put units, you're expected to put units. If not, then we won't overemphasize that just yet. We will later on, but right now focus on the concept, okay? Now, this next one is the segment addition postulate, but in a completely different manner. You'll notice, given this diagram, what you can say is MN plus NP equals MP. Again, when you take the two smaller pieces and add them together, you get the whole thing. Plug in what you know. The thing that I don't know is MN. I don't know what MN is, so MN is going to stay. All right, NP we know is 26, and MP is 32. Solve for MN. So we know that MN is 6 units long. Okay. Again, pretty straightforward, but it's a segment addition postulate in a completely different context. Okay. Example 4 here, start with your segment addition postulate. So KL plus LM equals KM. I want to see that on your paper, okay? I know it seems like a small thing, but I want to make sure that you understand big picture. Okay, so this here, once you have this on your paper, it shows me you understand what the segment addition postulate says. Now we just have to apply it and use it. Okay, so KL we know is X, LM we know is 3X, and KM is 22. Our task is to find LM. So first I have to solve for X. So 4X equals 22. Divide both sides by 4. So X equals 22 over 4 reduces down to 11 over 2. Okay. And so now if I want to find LM, I'm just going to plug that in. So LM equals 3X, and we know that X now is 11 over 2. So that's 33 over 2. You can leave it like that, or if you want to write that as 16.5, either one of those would be acceptable answers for me. Okay. If it said round to the nearest tenth, then you should find the decimal. If it says leave in fraction, leave in fraction. If it doesn't specify, then you can go ahead and do whatever you prefer. Okay, congruent line segments. Line segments that have the same length. Okay, that's what it means to be congruent. You have the same length. Okay, the way that we mark congruence, okay, as you can see in the diagram here, we use these little hash marks, okay, or tick marks, whatever you want to call them. I call them tick marks usually. Okay, so understand something. Okay, this statement here, the way you would read that is you could say it one of two ways. You could say the length of AB is the same as the length of CD, or you could say the distance from A to B is the same as the distance from C to D. All of those both mean the same thing. Okay. Now, once I know that lengths are equal, I can then say that they are congruent. Okay. Now notice, when I say they are congruent, I'm saying that segments are congruent. Okay. When I say they're equal, I'm talking about lengths or a measure. When I'm talking about the actual segments themselves, they are congruent. So you can go back and forth between these two. If your segments are congruent, what does that mean? It means that they have the same length. If segments have the same length, that means that they are congruent. Okay, so they're interchangeable, but just understand the different context. You would never say, okay, it would never make sense, and I'm going to kind of draw on the bottom here. It would never make sense to say AB is equal to CD. Segment AB is equal to segment CD. That does not make sense. Okay? Two segments cannot be equal. Two segments can have the same length, and if they have the same length, then you say that they are congruent. Okay? Again, just note there the congruent symbol. It's an equal sign with a little squiggly guy on top. And we'll use that a lot throughout this course. All right, it says plot the given points in a coordinate plane. Determine whether the line segments named are congruent. All right, so point A is 2, 2. Point B is 2, negative 1. So there's A and B. And then C is 0, negative 2. And D is 3, 1, 2, 3, negative 2. I should have done this in a different color. There we go. Determine if they are congruent. Okay, you might be thinking distance formula. However, since they are vertical and horizontal lines respectively, you can just count. Okay, so to go from A to B, you got to go 1, 2, 3 units. To go from C to D, you got to go 1, 2, 3 units. Check. They are congruent. Okay, AB is congruent to CD. All right, AB is congruent to CD. All right, so clearly that takes us to the end of the notes. As always, any questions that you have regarding this material, bring to class tomorrow, and we'll take those questions and clarify and make sure we're all on the same page.